This conference will now be recorded.
Yeah, good afternoon to all. Today we are going to look at few more interesting concepts of Unit 1. Okay. In the previous day's session, what we have seen? We have seen electrode potential, classification of electrodes, functions of electrodes, biopotential amplifiers, isn't it? So what is electrode? Electrode is nothing but it is a device, okay, or it is a transducer which converts one form of energy into another form of energy, correct? So those electrodes are classified into many types: surface electrode, depth electrode, needle electrode, suction electrode, okay? So a micro electrode, metallic electrode, okay, micropipette electrode. Many electrodes are there under classification of your electrodes. And functions of electrodes, Prerna, the electrodes are used to take the signal out of your cell, out of your human body, okay? That is, biosignal is extracted using this electrode. And biopotential amplifier, it is nothing but it is used to boost your low range signals which we are going to extract out of the human body, okay? So in small millivolt or milliamp range of signals will not useful for me to calculate or diagnose the patient's condition. So in order to diagnose properly, I should go for high range of signals, okay? So that is why I'm boosting my signal with the help of amplifiers, which is said to be biopotential amplifiers, right? Next, agenda of the session. So today we are going to look at ECG, okay? Electrocardiogram, the background, heart function, ECG waveforms and parameters, ECG electrode placements, okay? So have you heard the term about ECG, electrocardiogram? Have you heard the term electrocardiogram before? Definitely you could come across the word electrocardiogram. Through chat box. What is electrocardiogram? Sources of biopotential electrodes already we have seen. From where we have to extract the signal. Chest. Google chest. Good. Very good, Google. Good answer. So chest. Actually, it is heart. Okay. So we are going to diagnose the heart disease, the level of deceased person. Okay. How valves are blocked. What are the waveforms generated? Okay. What treatment can be given for your vessels block? Okay. All these details are going to be looked at in this ECG, electrocardiogram topic. Right. Very good answer, Gokul. So already you know that resting potential and action potential. Just brush up you. Resting potential is nothing but your cell will not generate any ionic current. Okay, how ionic current will be generated? By means of external source. Okay, your positive and negative ions present in the cell move from one place to another. That is from inside to outside. Okay, so that the movement makes ionic current in the body. So that will be grabbed by the electrode. Okay, so that ionic current is converted current using your electrode. So electrode is a trans. After getting electronic current, ionic current into electronic current, I'm going to give it as input to my amplifier to get boosting. Okay, so after boosting of my signal, I'll diagnose the patient. This is what happened by your biosignal. Okay, so in the first diagram, this is polarization of the cell. Second diagram, depolarization. Third, repolarization. Okay, the charge, look at the charge carriers. Finally, we have action potential. The positive energy gets inside and negative energy goes outside. Okay, so in the initial diagram, you have negative in the center, inside of the cell, and positive charge in the outside of the cell. Okay, so we have many chemicals present inside our human cell, like sodium, potassium, chlorine. Okay, many chemicals are present inside the cell. That chemicals are the basic fundamental thing to generate ionic current, right? So next is what we have: biopotential electrode basics. Okay, so already we know the basic, right? So interface between body and electronic measuring devices. It is used to conduct the current across the interface. Okay, interface is nothing but as we know, interfacing is connection, correct? So I'm going to connect my electrode with the body and one end of the electrode to the machines, right? So that acts as an interface. The current is carried in the body by ions. Okay, the current is carried by electronics by electrons. Okay, there is a difference between ionic current and electronic current. Okay, so next we have electrodes must exchanging ionic current into electronic current, right? And we have electrolyte. Electrolyte is nothing but which is used to increase the conductivity of the signal from human body. That is electrolyte. Okay, it is of tar material or charcoal or graphite. Okay, so all these materials can be used to uh, create your electrolyte paste. And this is bioelectric signals and their characteristics. Okay, so first one we have electrocardiogram, ECG. Already we have discussed this tablet column in the previous classes, I hope. Okay, excuse me. So next is what? Electroencephalogram. It is used to measure brain activity. Okay, and cerebral potential is also used to measure brain activity. That is cerebrum of the brain. Electromyogram. Myo is nothing but myo means muscle. So muscle contraction and retraction will be measured using this electromyogram. Okay, expansion, everything will be measured by using electromyogram. And electrogastrogram is used to measure gastrointestinal tract, whether the tract have any ulcers or not, the food is properly going inside or not, our digestive system will work properly or not. Up to the law, we will measure using this electrogastrogram. And electroretinogram and oculogram is used to test your vision. Okay, vision system. This is few bioelectric signals and their characteristics. Okay, the electrodes are different for measuring different organs of the body. Okay, we should not use same electrodes for all the measurement of organs. It should be vary, and the voltage range, frequency range is also being varied. Okay, from one organ to another organ. And next we have diagram. Okay, so this is this topic which deals with heart rate. So normally, where is heart is located? Your heart is located at the back of, okay, back of your ribs. Okay, these ribs are used to protect internal organs. Okay, so this skeletal view. Okay, okay. So heart is this skeletal view. Okay, the back of your ribs, because this is used to protect your internal the back of your, this soft organs. And here when you look at this diagram, you have internal internal organ. This is your lungs and this is your heart, this is your liver, this is intestine, like that it goes. Okay. So your heart function is working along with the function of lungs. Okay, so that it will pump the blood from the organs of the body. Okay, so pumping action by from your larger vessel one would heart. So this present the that is aorta heart. Okay, aorta with your and this is your lung. Next is E. So next EKG. It's cardio. It's used to record heart. It is one with okay. Number one is heart. As you can see here, this heart straight having some electrodes. So as you can see, first of these is very intense. Okay, so that the waveform will be better. Place as or some places will not like there are particular signal to measure particular you have a right.
Hi, how are you?
So in this you have seen a machine right presence the PQ this is speaker or it's called ECG performs like this. This is called PQ or okay, depending upon share. This is waveform only. The heart function will be measured. Okay, so this is connected. These electrodes are connected to the machine. Electrode will be maximum space of gram. Yes. Any doubts? ECG. Okay, ECG works mostly on the skin, large and spread during a point where we can. This is detected electrodes. Okay. So this is detected as a tiny rises and falls in the voltage between two electrodes placed either side of the heart. Okay, so this is a SA node, sinoatrial node. This is used to generate potential out of the human heart, and the rises and falls of the signal will be measured between two electrodes. One is your reference electrode, another one is your uh, reference electrode, another one is your main electrode, where I'm going to extend the biosignal out of your heart. Okay, so that signal will be given as input to my amplifier to get strengthening one. And next we have the heart electrical systems. I told you right, sinoatrial node, SCA node. So that is present at the top of this heart. Okay, so this is sinoatrial node which generates potential. Okay, so biosignal will be initiated and generated by this sinoatrial node and atrioventricular node, AV node. Okay, so we have this is your atrioventricular node, AVN. And next we have his Purkinje fibers. Okay, so his Purkinje fibers are in it like a fibers. I mean, எப்படி சொல்றது? A fiber like structure. Okay. Uh, கொஞ்சம் மசில்ஸ் மாதிரி இருக்கும் இல்லையா ஃபங்கை ஆல்கே எல்லாம் ஹேர் லைக் மாதிரி இருக்கும் இல்லையா தட் இஸ் கால்ட் இந்த இடத்துல ஹிஸ் பர்கஞ்சி சிஸ்டம்ஸ் பர்கஞ்சி ஃபைபர்ஸ்னு சொல்லுவோம் ஓகே ஸோ ஹியர் யுவர் ஹார்ட் இஸ் டிவைடட் இன்டு 4 chambers. One is right atrium, left atrium, right ventricle and left ventricle. Okay, so here from the diagram you can see left atrium, left ventricle and right ventricle. So here you have right bundle branch. Okay, this is called right bundle branch. Here we have a left posterior fascicles and left bundle branch here. The the point where you have separate between the ventricles, that is said to be your bundle branch. Okay, this is bundle branch, left bundle branch, and this is your right bundle branch. Okay, and this is left anterior fascicles. So this is anterior fascicles. Posterior fascicles is present in the top, anterior is present at the bottom. Okay, so this is fascicles. So a heart is divided into four chambers. So right atrium, right ventricle, left atrium, left ventricle. Okay, so your heart is blood is coming inside this atrium. Okay, and moves towards your right ventricle and comes back to the left ventricle and moving to my left atrium, and through my vessel it goes out of the body. Okay, so the blood circulation of heart is like this, so that the pumping action takes place. When the atrium contracts, the ventricle expands. When the ventricle contracts, the article expands. Okay, the simple cellular electrophysiology. So cardiac cells in the resting stage electrically polarized, that is no charge will be takes place. Okay, so when we have charges in the cardiac muscle, when we have a charge in the cardiac muscle, if we have any changes of my charge particles inside and outside of my cell, then only I'll get ionic current. Okay, so this is maintained by membrane pumps to ensure appropriate ion distribution to keep the inside cell electronegative. Okay, I told you already that we have some chemicals present in the human cell, that is potassium, sodium, chloride, calcium, everything is present, but major component of for generating ionic current is potassium and sodium, right? So the cell loses the internal negative during depolarization, negative charges. Okay, and cell restores their resting polarity during repolarization. Okay, resting polarity, repolarization. Okay, resting polarity, repolarization, and it loses the electron, then it's said to be depolarization. And here electricity and the heart. Okay, so how electricity and the heart related with each other. So we are going to have pacemaker cells, electrical conducting cells, myocardial cells, depolarization, repolarization. Okay, five basic important topics are under your electricity and heart. Okay, pacemaker cells. As you can see here, this is your bundle fibers, and this is AV node. This is his bundle fibers. Okay, four chambers is clearly shown in the cross-sectional view of this heart, right? And next we have pacemaker cells. I told you, right, there are five important functions or parameters to be considered for electricity in the heart. Number one is pacemaker cell, electrical conducting cell, myocardial cell, depolarization and repolarization. So under that, first one is pacemaker cell. Okay, so pacemaker cell is nothing but a power source of heart. Okay, so we are going to place a source which is used to trigger the heart muscle. Pacemaker வச்சிருக்காங்க சொல்லுவோம், stent வச்சிருக்காங்கன்னு சொல்லுவோம். We could have heard that terms, right? Open heart surgery பண்றாங்க அப்படின்னா they are the patient are implanted with some other foreign material like stent or stem. Okay, so many biological factors are there to uh, implanted your uh, foreign material inside your heart. Okay, so the electrical power source of the heart, one of the electrical power sources, pacemaker cells. So the dominant cells located at in sinoatrial node area of the heart. Okay, where we are going to place our pacemaker is, it is at the SA node, sinoatrial node. Where is sinoatrial node? At the top. Okay, here we have sinoatrial node. And next, able to depolarize over and over. Okay, so first at rate 60 to 100 times per minute, depends on the activity of automatic nervous system. This is used to give power source to the heart. Okay, Charging and discharging continues for 60 to 100 times per minute. Okay, each depolarization initiates one complete cardiac cycle, contraction and relaxation. Cardiac cycle is defined as the combination of contraction and relaxation of cardiac muscle. So this particular pacemaker cells gives 60 to 100 times per minute. Okay, so this is a one power source of heart. The next one is myocardial cells. Myocardial cells is nothing but it is again a source, power source of heart. Okay, major part of heart muscle is myocardial cell. So that it is responsible for repeatedly contracting and relaxing, forcing blood to rest of the body. So what happens once the contraction and relaxation of heart muscle will not takes place? Pumping action stopped and your breathing rises as like anything, right? So if you struggle in breathing and if you struggle in having blood to all the other organs of the body, then what happens? Your heart function stops and the people will die, correct? So this should not be happen, so that we are going for a power source, external power sources. So myocardial cells, this is also used to uh, contract and extract the heart muscles in the absence of your no, natural operation. Okay, and next comes we have depolarization. So when we have depolarization, consider an advancing wave of positive charge within heart myocytes in turn causes progressive contraction of myocardium. Depolarization அப்படின்னா contraction. Okay, so contraction, depolarization. Okay, relaxation, repolarization, right? So here you have positive charges. Okay, due to contraction, these positive charges are tends the capability to move inside your heart. Okay, so during contraction, this positive charge present in the outer side will tends to move inside the heart cardiac muscle. This is depolarization, right? So this is next is sinoatrial node, heart's dominant pacemaker. This is called heart dominant pacemaker because this is your power source. From this point only we are going to get myosignal, and this is having the ability to generate pacemaking stimulator known as atomicity. Okay, so this generate pacemaking stimuli. Naturally, this SA node stimulate your heart pumping function. Okay, so depolarization of atria detected by electrodes. Okay, so naturally what this SA node will do is it is used to contract and relax the muscle. So during that time we are going to have depolarization and repolarization of heart signal. Okay, so that it will be grabbed by the electrodes. Okay, it's noted as P waveform on the EKG. Okay, SA node generates P waveform. Okay, that is said to be atrial depolarization. So next, variations of the P waves. Okay, this is P wave, which is responsible of generating your PQRST waveform. SA is responsible for generating PQRST waveform. Out of that, P waveform is very important to diagnose. That P waveform variations are given here. Okay, whether we have tall rounded or tall peaked notched P waveform or wide notched or biphasic. Biphasic na malic helium. Okay, so if you have P waveforms under any of these criteria, then you will have definitely problem in the heart. Okay, so tall symmetric peaked waveform seen increased right atrial pressure. So if you have more pressure, then this tall symmetrical and peaked waveform will be generated under P category, right? So notched and wide seen in increased left atrial pressure. Okay, so atrial pressure represents or um, reflects in the P waveform. Okay, either it is right or left, no matter, that pressure is reflected in the P waveform. Okay, so if you go for biphasic P waveforms, okay, both R and L, right and left atrial dilation will appear. Okay, so contraction will take place, right? So depending upon our contraction expansion, the P waveform will be. Okay, next, atrial contraction. Atrial contraction, depolarization slows within AV node. Okay, So depolarization slows AV node. The charge carriers will get reduces, okay, under repolarization. So here allows blood from atria to pass through AV walls into ventricles, okay. So this is your P waveform. This is your P waveform. We have a pass over here. Okay. So what happens in the pass? Here, it allows your blood from atria to pass through AV walls into ventricles. So AV walls வழியா இங்க இருந்து உனக்கு ventriclesக்கு it will pass the blood. Okay. Here we have one uh, vessel. Here we have one vessel. Okay. So that allows blood to flow from atrium to ventricle and ventricle to atrium. Right. So this PR waveform, this PR interval is used to measure the time from the start of atrial depolarization to the start of ventricular depolarization. Okay. So what is depolarization? Positive charge tends to move from outside to inside. So that will have some ionic current. Biosignal will be takes place. Okay. So if it is present in atrium and ventricle, we are having waveform like P and R interval. Okay, so P and R interval will be taken, and the interval lasts from 0.12 to 0.2 seconds. And ventricular depolarization. So ventricular depolarization means it starts slowly but picks up speed in the bundle of his fibers. Okay, so here depolarization quickly distributed to the myocytes of the ventricles via terminal filament of Purkinje fibers. Okay, it produces ventricular depolarization produces QRS waveform. Okay, your AV node creates your P waveform. Understood? PQRST waveform is generated as ECG waveform. Out of that, P waveform will be generated by SCA node. Okay, and here you have seen atrial contraction PR interval. During atrial contraction, PR signal will be generated and ventricular depolarization QRS signal will be generated. Okay, it lasts up to 0.06 to 0.1 seconds. And this is your ventricular contraction. Okay, so the filament, terminal filament of Purkinje fibers, this is fibers, right? So here we have ventricular contraction. Contraction na surungaradu, expansion na viriyaradu, சரியா? So here ventricular contraction. So this is your pulmonary artery. This is aorta. Aorta is the largest blood vessel present in the human body. Okay, through this aorta only the blood, purified blood will be supplied to other parts of the body, other organs of the body. Okay, so this generates, this ventricular contraction generates QRS waveform. Okay, ventricular contraction generates QRS waveform. And QRX complex. What is QR and yes? So Q first negative. So this is your first negative. This is called Q waveform. Reflection of QRS complex. Sometimes absent. Sometimes this will not happen because very small amplitude, right, in the negative direction. It will not happen sometimes. Okay. So R waveform is nothing but a positive waveform, upward direction of QRS complex. And S is again downward wave preceded by the upward wave. This is upward. Okay, this is negative. This will be absent sometimes, and we have upward direction signal. This is R signal, positive signal, and here the same negative signal will be present as S waveform, downward wave preceded by the upward wave. This is your QRS complex. Okay, and next comes we have ventricular repolarization. Can you able to follow me? Am I fast? No, right. And next is what? Ventricular repolarization. So here we have ventricular repolarization. It represents initial phase of the ventricular repolarization. So this is your depolarization. Okay. Charge is moving from inside and outside. Depolarization takes place. And here we have repolarization. Okay. No charging takes place. No movement of ions will be present in the repolarization phase. Okay. So it actually lasts up to 0.08 to 0.12 seconds, and T waveform. Okay, this is T waveform represents the final rapid phase of repolarization. So the K plus ions leaving myocytes. Myocytes அப்படிங்கிறது cardiac muscle தான் myocytes னு சொல்லுவோம் சரியா. So this is ventricular repolarization, lasts up to 0.8 to 0.12 seconds. And QT interval. Okay, so what is QT interval? The signal starting from this point to T. T is nothing but your repolarization, correct? This is your T waveform, repolarization. So the time between your Q and T is said to be QT interval. So this QT interval represents the duration of ventricular systole and is measured from the beginning of the QRS until the end of the T waveform. Okay, so this is the signal which we have taken from Q to T, that is QT interval. Okay, and the QT interval is affected by many factors. நிறைய factors it affect ஆகும். Okay, so mainly it is taken from contraction, ventricular contraction we have taken this QT interval. And from this diagram you can easily understand atrial depolarization. Okay, here we have atrial depolarization, P waveform, and here we have QRS wave, ventricular depolarization, QRS waveform, and plateau phase, resting state, no signal will be generated, and we have rapid phase. Okay, this is done by your repolarization, ventricular repolarization சரியா. Depolarization தான் signal ஜாஸ்தியா கிடைக்கும். Look at the diagram. Depolarization signal ஜாஸ்தியா கிடைக்கும், movement of ions will be there. Okay, so மத்த phases எல்லாம் பார்த்துட்டா ions கம்மியா தான் இருக்கும், that is repolarization phase, repolarization or resting phase. Okay, so this is PQ or ST waveform of cardiac muscle. And U waveform. U waveform is medically curiosity. Okay, this waveform is not clear when relationship it has with cardiac activity, but it is thought to represent repolarization of the His-Purkinje fibers. Okay, His-Purkinje fibers is also used for repolarization. It will generate U waveform. Due to weakness of the signal, the U waveform is not often seen in the ECG. Okay, PQRST U இருக்கு, அது வீக்கா இருக்கிறதுனால it will not obvious, it will not visible to the physician. We can neglect this, no issues under U waveform. Next we have J point. Okay, so the point at which the QRS meets the ST segment. ST segment is that is time between your S and T. Okay, that is said to be your J point, end of ventricular depolarization. So this J point on the end of depolarization, ventricular depolarization, and it is a landmark for measuring QRS duration. J point is end of ventricular depolarization. Just simply understand that it is a end of ventricular depolarization. And ECG waveform. What is P waveform? P waveform will spread, signal spread from SA node. SA node will be generated your P waveform. Okay, so to make the atria contract, PQ signals segments, it is signal arrives AV node, stay for the instant to allow the ventricle to be filled with blood. Okay, this is PQ, filled with blood. Blood உள்ள போறதுக்கு கொடுக்கிற டைம்ல PQ segment. Q வந்து Q waveform. After the bundle of His, the signal is divided into two branches and run through septums. Okay, RS waveforms contraction, ventricular contraction RS வருது. T is ventricular relaxing. Okay, ventricular contraction அப்போ ஒரு signal, ventricular relax அப்போ இன்னொரு signal will be generated. And next ECG signals. So low differential voltage from 0.4 to 0.95. Okay, and high common mode rejection ratio, low frequency range, high noise. These are the specifications of ECG signals. Okay, so high common mode rejection ratio, so that the noise will be eliminated, and low frequency range, high noise. Okay, it is very sensible to high noise. And ECG signals artifacts can have many causes. Okay, so if you have taken your ECG waveform, in between if you have any artifacts, that is disturbances, then the signal will not be properly measured. Okay, that should be taken care of. The artifact should be taken care of. How artifacts will be generated? So due to some electrical interferences or misplacement of your electrodes or improper placement of electrodes, all these are factors influenced your ECG signal. And we can see your heart in different views. Okay, so from the diagram, what did you understand? Each ECG lead provides a different view of the heart. Okay, so we can place our electrodes in under which view we are going to look at. Okay, so we have different views of the heart here by placing your electrodes. So ECG electrodes, we have many electrodes, say for example, say 5 to 6 electrodes can be placed over the body. Mainly, it is connected with ground and your reference signal. Okay, so this diagram shows the difference between two potential on the body surface is called ECG signal. So here you have a electrodes. Okay, these two electrodes is connected in these two places. Okay, along with the resistors. Okay, this is connected to my differential amplifier. One is positive and the other one is negative. So the difference between those two signals will be taken out and is amplified with the help of this differential amplifier. Okay, so that output will be measured for diagnosing the heart function. Your leg is grounded. Did you notice this one? Your leg is grounded. You have taken your two electrode over the chest. And from this diagram, we have easily understand the concept. The cross section of your heart is shown here. If we want to look at ventricle or sinoatrial node or auricle, anything precisely, then we have to place our electrode in such a way. Okay, so here you have around 6 electrodes in the body of the patient, and we have 2 electrodes on either hand, either side of wrist of the hands. Okay, and we have 2 electrodes at the patient's knee. Okay, so all these electrodes put into a single machine which gives PQRST waveform. This is limb and chest leads. It is called limb and chest leads. Okay, this is lead, again another lead position. Okay, so we have limbs and chest. So we are placing 2 electrodes in the hands and 1 electrode at the left leg, and one is acts as a ground. One leg is acts as a ground, and we are going to place few electrodes over here over the chest. Okay, this is the placement, proper placement actually. V1, V2, V3, V4, V5, and V6. Okay, these rib cages are also taken into consideration for placing electrodes. That is a reference point. Okay, that ribs are reference point. Rib 1, rib 2, rib 3, like that. We are going to place our electrodes over the chest. And ECG electrodes. Okay, typical surface electrodes are used. Surface electrodes can cover maximum space. That is why we are using a surface electrodes, which is made up of silver chloride. For easy connectivity, conduction of your signal will be takes place using silver chloride. Okay, that should be attached to the patient's body. We can also use disposable ECG electrodes. Already we have seen this is right arm, right leg, and left leg. These are all some places to place our electrode to measure ECG waveform. This is origin of signal. Can you look at the diagram? Origin of the signal. Okay, here you have two hands, one leg, and here we have 2 legs, 1 hand. Here 2 legs, 1 hand. Okay, everything is connected to amplifier and common mode rejection ratio. High common mode rejection ratio reduces noises. Okay, amplifier increases signal or strengthen the signal. This is one of the method of placing electrodes. Okay, right. So this is first rib, second rib, third rib. Likewise, we are going to have the count of the ribs, and the electrodes are placed in such a way here. V1, V2, V3, like that. Okay, so that the heart function and the biosignal will be extracted, and it is given as input to this machine to get the output in the paper. The waveforms in the paper. This is suction electrodes. In the previous diagram, you could see surface electrodes. Here we have suction electrodes. Okay. That's all today's session. So ECG got over. If you have any doubt, let me know. No doubts? If we have no doubts, then we will wind up the class. No, ma'am. Okay, right. So expand ECG. I'll explain this question myself. Expand ECG electrocardiogram. This is sinoatrial node, which is used as a power source. Arteries and veins are giving blood from and to the heart. Okay, from the heart and to the heart, their arteries and veins will carry the blood. PQRST waveform is nothing but the ventricular depolarization and atricular repolarization that gives this PQRST waveform. And next ECD electrode, ECG electrode material type, and it is of silver chloride. Okay, silver chloride. Sometimes we can use disposable electrodes and suction electrodes for measuring electrocardiogram. This is ECG. Sorry, D போட்டிருக்கேன். G. Right. So that is today's session. We'll meet in the next class. Thank you. Class dispersed.